perfect. Nishant, you can see Dr. Ravindra Kumar.
Sir, this is a nostalgic moment for me actually, sir.
Yes.
जब कॉलेज में दूसरे साइड बेंच पे बैठते थे, आज कॉलेज में दूसरे साइड से मैं बच्चों को देख के पढ़ा रहा हूँ, तो that is an amazingly good experience actually, sir.
Yes, you can see the lecture theater.
Yes, I can see now.
Yes, the students of MSc class, they are sitting in the classroom, and the other students, they are maybe in the undergraduate classroom, taking precautions under the corona protocol. We are not having much of the students in one classroom. That's why separating MSc, PG, and UG. And Nishant, one more good news that after your presentation, we are going to have a quiz on GIS. And
That's
maybe
perfect.
and the questions may be related to the presentation which you will be giving.
Oh my goodness, that's good.
Only the basics one. And the other aspect is we will have a PowerPoint presentation by students also on applications of GIS in earth science. And we have also requested the students for poster designing on GIS. So these three events will be under the competitive segment of Platinum Jubilee. So we'll wait for maybe another 5 minutes and then we'll start. Okay.
ज्वाइन हो गया सर।
हमारे जितने भी पार्टिसिपेंट्स हैं अपने इस कार्यक्रम में ज्वाइन करने वाले सभी लोग अपने स्पीकर को म्यूट मोड में रखेंगे। अभी भी मैं देख रहा हूं कि कुछ लोगों ने म्यूट नहीं किया है, इसलिए आवाज में परेशानी है। सोहन जी, आप आवाज देखिएगा, बहुत तेज नहीं होनी चाहिए। लेक्चर थिएटर में जितने लोगों तक आवाज पहुंच सके सभी स्टूडेंट्स अपने मोबाइल फोन को म्यूट में रखेंगे। हेलो हेलो स्टूडेंट्स, आप लोग अपने वॉल्यूम थोड़ा सा कम रखेंगे। सोहन जी, कहीं से कोई डिस्टर्बेंस नहीं हो। वॉल्यूम और कम कीजिए सोहन। सोहन, आवाज ठीक है? मेरी आवाज सही जा रही है सोहन? नीचे से हाँ, वहां से दूसरे लोगों को म्यूट नहीं कर सकते और लोगों को, क्योंकि आवाज क्यों ऐसा आ रहा है। और वेद को बुलाइए ना, आप आइएगा, और थोड़ा सा कनेक्शन अभी रखेगा। आप वहां देखिए मेरी आवाज कितनी तेज जा रही है। वेद प्रकाश को पहचानते हो ना? कहाँ है, देखो तुम नीचे अच्छा, नहीं उसको यहीं रहना था ना, वो देखने के लिए कि आवाज कैसी आ रही है। या आप देखिए। हेलो 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 हेलो
हेलो
हेलो Hello, 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 hello. तो सर वो आज लग रहा है वो उसको वॉल्यूम पे कम रखे। प्रकाश सबको उसी से करने दोगे क्या? अपने मोबाइल से लिखेगा। गया नीचे लाने क्या? सोन बोला कि लेकर क्या नीचे से। Nishant ji, are you ready now?
Yes, sir.
Okay, yes, Nishant is ready.
Yeah.
And the students are also there in the classroom as well as those who are attending through their own system. So good morning, everyone. Really, it's again moment for pride for all of us that one of our bright alumnus is with us under the Platinum Jubilee lecture series, which we are organizing under the Platinum Jubilee year of our university. As the students are aware that the department is organizing Platinum Jubilee, and we had the grand opening online in the month of August. And then since August, September, and October, we had three very, very distinguished presentation by our seniors. And today, fourth lecture under the Platinum Jubilee series, we have another bright student of our department, Dr. Nishant. Today, it's also important day for the Earth Science fraternity because the global fraternity in Earth Science, we are celebrating GIS Day, that is Geographic Information System Day. And it's one good opportunity to have a presentation on GIS today by none other than a bright professional alumnus of our department, Dr. Nishant. Before Nishant starts his presentation, I would like to introduce the speaker to the students of this department as well as other members of the Platinum Jubilee group who are witnessing this program. And I must introduce myself. Those who are joining through other means, that I am Atul Aditya Pandey, head of the Department of Geology, and sitting beside me is Dr. Ravindra Kumar, the undergraduate Department of Geology, Patna Science College. So welcome all the faculty members, students, alumni of the department, and other teachers joining this program today on the eve of GIS Day. Today's speaker, Dr. Nishant, is head of products at Times Internet, which is the digital arm of the Times Group, the largest media conglomerate in India. Nishant is an alumnus of the Department of Geology, and he has more than 22 years of rich experience of managing global team, defining global product strategy, developing technology products, analyzing product life cycle, and setting up global product practices. Prior to joining Times Group, Nishant was holding global role of Director of Engineering for Pitney Bowes, that is the software company, global software company, 100 years old, having NYSE and Fortune 500 company headquartered in US with a valuation of more than $5 billion. Nishant has a rich experience of global deployment of product solutioning in more than 30 countries and successfully built a portfolio of more than 120 countries. He is a globetrotter, and his customer centricity as well as skills of managing global customers lead to more than 80% of repeat businesses. We are very happy that Nishant started his career with DRDO, Defense Research and Development Organization, Defense Ministry of Defense, Government of India, and he was awarded with Young Scientist Award in the year 2000. So let's clap for Nishant, who was awarded the Young Scientist Award in the year 2000. Now, Nishant is having PhD doctorate degree in data analytics from Terry University, India. He is a certified machine learning and artificial intelligence practitioner from Google, acquired business management skills from Indian Institute of Foreign Trade, India, and INSEAD, France, Stanford University, US, trained in negotiations and strategy from ISB, Hyderabad, professionally trained in product management from Pragmatic Marketing Institute, USA. So overall, I must say that we have a very bright professional involved in this industry, and we are very proud to have our alumnus working in this field. So now, may I hand over the mic and assignment to Nishant, who will be talking about the GIS. And as you must have seen, that his presentation is GIS Beyond Maps. So thank you, Nishant, with us. And now you may take over for the presentation.
Thank you, Atul sir. Nostalgic moment for me to join in on a GIS day, going for the lecture on GIS Beyond Maps. And just I shared the link with Dr. P.K. Joshi from JNU, who is my guide in PhD, and he too has joined this series actually, and he is there along with us now.
Welcome, Dr. Joshi. Welcome, Dr. Joshi, to this Platinum Jubilee lecture of Department of Geology, Patna University. We are all very happy.
Well, thank you very much. Indeed, it is a pleasure. Thank you.
So, honorable teachers and faculties, alumnus, and my dear students, what a good day to start a GI.
There is some problem with the link. Nishant, is there any problem? Nishant, you are not audible. Nishant Sinha has left the meeting.
Am I audible now? Am I audible
Yes.
now?
Yes, you are audible. Yes.
I'm so sorry. There was a power failure at my place, and uh, what a way to start. Actually, Murphy's law always says like whenever you start a presentation or a demo, there is going to be a glitch. So that is how it started with. I'm happy with that. Like everything goes well. That ends well. So I'll start with my presentation now. Okay. So my topic is GIS beyond maps. Looking at this image, actually, if you have everything, every detail that is available in a map, location, the context of the location, the map of the location, as well as the scale of the location, and at whatever details that you require is available in a map, and you are standing in mid of a sea on an island where you see this kind of geological or GIS map, what is the use of this map? That is where I will start my discussion. Is this GIS map that is provided to you is useful for any of the application or any of the purpose that you want to utilize? That is how I'm starting this presentation. That is a point to think across. Is the GIS only about the maps, or is it beyond the maps to discuss about, or beyond the maps, this GIS application that is useful? That is how I will start. Always started with everything is related to everything else, but near things are more related than the distant thing. So how do you correlate from one place to the other is on the basis of the details that is available in surrounding to you, and you correlate those surroundings, and those details provide you the context how you want to go ahead about it. That is how I see that. And that is how I see GIS is just not about the map, but it is beyond those maps, what I would like to talk about in this presentation on a GIS day. The question to you is this Apple a spatial data? Or is this Apple spatial? Whenever we look at a map, or whenever we look at a data which is having a spatial component, everything we relate it with GIS or the maps or the spatial or the latitude or longitude. So my question to you is this Apple a spatial data? Or is this Apple spatial? Is Apple spatial? So all these three questions need to be answered. When I see the maps on this Apple, with the maps that is denoted or the maps that is holding the data, which determines like from the data set by which I can recognize which is Africa, which is South America, which is North America. So those data are spatial data, whereas the Apple is the platform. That is how GIS has to define across. So different kind of data that consist in a GIS data that is spatial data and the attribute data that makes it complete for a GIS purpose. How do we represent this digitally in a GIS? By grouping into different layers, or by grouping into different kind of data models like vector data model or the raster data model. That is how we define the GIS platform data with the help of projection, scale, accuracy, and the resolution. So give me a second. Yeah. So how do we incorporate the computer application system? Is through the database management system that is available that connects the dots of the attribution layer with the spatial boundary layers that can have three different kind of components, that is point, line, and polygon. That is the basic nuance of any GIS or any GIS data analytics. I will go GIS as a geographical information system. And I always say like a system that doesn't hold a map or a picture, but holds a database. That is how I define a GIS system. GIS system, if it has to be defined, a computer-based system for the manipulation and analysis of geospatial information in which there is an automated link between a data object and their spatial location. You have details available. Wherever you Google, you'll find all the details, all the data set, everything over there. Let us Google and let us search what is the history of GIS. So if I start with 1970s, so 1970s onwards, this GIS evolved across. Roger F. Tamilson, whose birthday is on 17th November, that is today, on whose name this GIS Day is getting celebrated, he is known as the father of GIS. So, so he started those digital platform, geospatial analytics platform. At that point in time, very limited companies like ESRI or Rolta, so all those companies were available at that point in time, which started doing different kind of analytics, which started growing across. Where in 1995 to 2000 era, the internet GIS came into play. Then the mobile GIS from 2004 onwards, the mobile GIS started playing a lot of bigger role. In between the SDSS, or we can call it a spatial decision support system, that started into, and that started as a mid layer which were integrated with the data set layers as well as the decision support system. So all different kind of decision support system integrated with GIS started providing so many different results that we wanted to utilize for our business application. So that is how this entire GIS growth or the DSS research system grew together to get you the insight from GIS. I'll talk about some of the historical aspect. So 1858. This person is Geospat Felix Tomachon, popularly known as Nader. So he started using balloons for capturing the photographs of the land area of the land area of France, and he started capturing across a France data set or the photographs through the photographs, and tried to map across different naming convention of different street. He started marking across. Nader, that is how he was known, actually, Nader. So we still call like Nader view. So that is all. The Nader is this person's name as a synonym for his contribution, actually. These are the pigeons, actually. Like so Bavarian's pigeon that were known for holding a camera and taking the snapshot of different areas of the enemy's troop. Actually, these cameras were enabled for 15 photographs in 30 seconds time frame, so that, and they used to go capture the photograph of the enemy territory, and they used to get back to their base station for different kind of and this data was analyzed. And certainly, yes, I can't say like this is the start of the remote sensing, or this is the start of the GIS period, or this is the start of analyzing point, line, and polygon. But yes, this is certainly a contribution factor towards the GIS what we are using as of now. These are the actual pigeon pictures that was coming across. Then Wright brother came in when this plane, they invented the aeroplane, and that aeroplane started getting into the airborne mode and started capturing the photograph. And these are the photographs that was captured through the first flight of Wright brothers at that point in time in France. This is one very good use case, actually, in 1962, when Cuban had a conspiracy around like creating a ballistic missile range across by camouflaging. So the entire area was camouflaged. So by the satellite, by this aerial photograph images, this was undercover. This was discovered, or this was found out actually by the US militaries that Cuban government is trying to create a ballistic missile range in their area. And that is how this was one of the earliest application of GIS and remote sensing at that point in time in 1962. World War II World War II was an era when GIS and remote sensing grew up, and it gave many multiple dimensions to the GIS world actually. Current engagement, if I look at, GIS is looking more sophisticated now, where it caters to the individuals, to the team, to the departments, to the organization, to the communities, and moreover, multiple machines with the IoT devices. So this has become more complex, but it starts giving you more better result in terms of result. It is more comprehensive, more accurate, and that is how I see this entire product coming across and growing across in this period of time. So there is something somewhere it has gone wrong actually. Like as a human being in the evolution series, from the monkeys to the person, again the posture remains the same. Only the technological development has happened. Our dependency upon the technology has gone so high that those old days of creating the map or visualizing those maps has been lost across, or we don't know the science and art of creating those maps, or science and art of interpreting those maps. Basically, we are too much dependent upon the machine. So still, when I'm talking about GIS and the geospatial or geographical information system, I encourage my student to know or understand the basics of the science actually. So GIS is all about the science, GIS is all about the art, GIS is all about the philosophy, how to get the value from those point, line, and polygon, how to create that should go as a learning, not should be a computer dependent. That is how I wanted to put across this photograph, especially for the young generation, those who are learning GIS. So the choice is yours, basically. What you want to be. You want to be an analyst using a computer system, or you want to be scientist who can derive, or who can create a machine, who can create a system that does the GIS for you. So that is how I see this entire value chain has to be leveraged, not to be captive of this value chain actually. So that is how on GIS Day, this is 1 cent from my side for all the students who are attending the session. I'll go with one word at a time. What is GIS? So G already we know, it is geography, latitude, longitude, addresses, whatever you call, whichever denotes across the location part of it. So that I will not cover across, but I will emphasize upon I and S. So I'll go with one word at a time. What is information? Information is all about data, and data is a fact and collection of the facts. Data that is processed, organized, structured, or presented in a given context to make them useful, that are called information. And that is how data becomes the core of GIS. Data becomes core value of the geospatial data, geospatial product actually. Now, if I go to the system, what is a system? System should have an input as well as output. It is a set of components for storing, displaying, analyzing a data. Whenever you query the data, it should give you a response. And that is how this GIS complies different. These are the 3 different acronym words that gives you the detail what this system will look like or what this system is all about. What is GIS? What is S in this GIS? The definition of S has changed many a time, different time period based upon its uses, based upon its application, based upon the way people have utilized it. In 80s, it was called as a system, like MapInfo or ESRI product and ArcGIS. So all of those were systems which were giving you result. So technology or the acquisition or the management of a spatial information, that was the core work of the GIS product. Software for professional users or the cartographer. So this was a kind of software application. That is how this was known as a system. Whereas in 90s, it became more science than the system. It was comprehending the underlying conceptual issues of representing data and processes in space-time. That is how this was defined as a science during 90s, the science or the theory of the concept behind the technology. And we all emphasis upon those science part of it rather than system. Again, in 90s, late 90s, it became studies. People started using GIS for different kind of analytics, different kind of studies, different kind of research. That is how it became studies. Whereas in 2000, most of the commoditization of this product started happening across, and it became services, where the website on which your traveler's website were there or Google Earth came across. So during that period of time, it was more of the services than the system or a science or a product. So again, what is GIS? GIS means storing, mapping, and analyzing the spatial data. It has information system as well as geographical positioning system. Geographical positioning. Now look at this. Look at this face, which has got a map. Is this spatial data? So again, the face is a platform on which the spatial data layers has been overlaid on each other as a GIS layer. Yes, this platform of the face is representing across a plethora of information from those maps that you can derive for your business uses. That is how I define GIS at this moment in time. So GIS involve what? The software, the data, the people, the methods, and the hardware. So if you look at the right side of the image, it rightly expressed the GIS system. The spatial data. So this part is the spatial component of it. Let me put up my pen. So this part, if you look at this part, this is the spatial, this is the temporal data, and then the mechanical hardware system and the mapping component, as well as different kind of softwares and the hardware machine and the networks and the cloud networks. So all of that, along with the historical background of the data, historical monuments, that means like you are going to the field, capturing the data. Again, you are references of the data points and the mechanical data that leads to the temporal and the spatial component of it. And in the center, there is a human who analyzes, who interprets, who does the services, extract the value out of these GIS layers to get the business a business problem solved. That is how I see this component as a GIS component, which has got a hardware, which has got a software, which has got a data, which has got involved people, which has got different kind of methods. So GIS can be applied to any of the application, any of the use cases, wherever the location services are important, wherever the information of the location is important to analyze or to get the business value out of it. So GIS, it has leaving us with a simple way to start learning about GIS is a tool for deriving the information from any data with a geographical spatial component and the basic of storing, mapping, and analyzing spatial data. And answers the following. That is the most important part. Otherwise, GIS, most of the people, most of the use cases get limited to the maps, which is not the case. It should answer the following. That is the important aspect of this GIS part is location. What is at? That means the first of this question seeks out to find out what exists at a particular location. So what is located? What is so the question is, a location can be described in many ways. Like, for example, the postcode. What is the postcode of that area? What is the name of that area? What is the geographical reference of that area? Or what is the latitude, longitude of the area? So these are the locational specific questions it should answer across. And that is how it is one important answer that our GIS system should give us or provide us. Conditions, where is it? So if you look at this photograph, this was the first ever use of GIS or the maps in a film poster actually. This film poster, Where in the World in Carmen, San Diego, is the first film photograph that used the GIS component, where to represent the different countries, they use the monument. And by using those monuments, actually, like in France, Eiffel Tower, in the US, the Statue of Liberty, all those photographs were created. And that was the first ever use of any mapping details for a poster of a cinema or poster of a film, actually. So the second question is the converse of the first and requires a spatial data to answer. Instead of identifying what exists at a given location, one may wish to find locations where certain conditions are satisfied. Where is Eiffel Tower situated? Or where is my Statue of Liberty is situated? So all this kind of question that my GIS system should give us as information. Then it should talk about the trend. What has changed since a particular time frame? The third question makes it more important, that says if you have the temporal data, and two temporal data should give you a basic information, what has changed since one point in time to the other point in time. Again, it should analyze the different kind of patterns. So the patterns are like, the association of those patterns means different kind of object that consists or that configures a map that provides you the detail of what it is as an overall, because one road is a road. One boundary of one boundary of a country is a boundary of a country. That is a point, line, and polygon. But what finally comes out as a association of point, line, and polygon, that association becomes an important pattern, a spatial pattern to solve the problem statement, to give you the answers, what exists where, what information it is giving you, what information it is trying to tell you across, and how the entire association is giving you the value to do a business problem solving. Again, it should give you the modeling as well. The GIS provides you modeling. It answers the question of what if. What happens at one point in time, like say example of a rainfall, like what happens if 30 millimeter of rainfall happen in 1 hour? It should be able to give a modeling aspect to those kind of nuances or those kind of questions that needs to be answered across. If a new road is added to the network, or if a toxic substance seeps into the local groundwater supply, what will happen? You should be able to model across. You should be able to model across all those different kind of nuances by using GIS system. It should answer some of the spatial questions as well. What is the average number of people working with GIS in each location is an spatial question. So it is all about people, but it is not about any geospatial specific questions across. That is how this spatial questions answers comes from your attribution of the data, not from a spatial component or the mapping component of the data. And that is how you can derive different kind of values from this from this GIS systems. It should answer the spatial question as well. How many people work with GIS in the major centers of Delhi, or which center lie within 10 kilometers of each other, or what is the shortest route passing through all these centers? That is how this should able to answer some of the spatial questions as well. More interestingly, it should give me the information. One GIS data layer combines both, that is geographical features as well as the attribution feature. So it should combine both the aspect of the information to give you the result or give you the answers for the business questions. Storing everyday geographical data, that is how I define like a point, a line, or a polygon. A 0-dimension product, or a 1-dimension product, or 2-dimension product. So that will give you the value. You have to define whether you want to represent So again, the question is like, I'll go with the question now. Like the question is, Delhi is a point, or Delhi is a polygon, or Delhi is a line. It will all depend upon what is the business objective you want to achieve out of it. A point can become a line can become a polygon. So that is how I see what dimension you want to extract as the information from this GIS system. That will define your basic nature of questions, or basic nature through which you want to capture across through the point, line, or the polygon. It should define or detail the outlier. So look at this image. Actually, I intentionally put up this image which says which is one is the outlier. You need not to redefine or figure it out. Basically, the outlier should come out automatically through my system, through the different models, through the different layer representation of my data that is available over there. It should be creative, the creativity to portray. This image is a half image, or this image is taken from the side. You have to think twice before you answer the question, because that is how GIS provides you multiple facets to a problem statement to analyze from different dimensions, or you can do a slicing and dicing of the data to get the different kind of information from the from the GIS models that you have built across. GIS is an amalgam of art, science, and technology. That is how we should define GIS. That should be our core fundamental to the GIS features or GIS insight, actually. So it helps to produce and analyze the maps to enable communication of ideas. The basic principle, again, the basic principle remains the same, has a clear motive or the goal, is directed towards the audience, use appropriate design elements to clearly convey its message. So you cannot use a different kind of innovation that makes it more complex to derive the business value. So you should stick to the basics to get you the best of the result. A dynamic way of representation. So GIS gives you a lot of flexibility around how those maps can be created. One of the most innovative maps that I've seen across is this map, where how the different telecommunication system or different mobile usages has happened across in different areas. So these are the spikes at different point in time for different cities of US, and their volumes of the call is represented by line, and from one place to the other is represented by arc, and that is how this entire GIS map has been created across. So this is one of the most innovative way of representing a map. So before you before we proceed further, like the GIS should be taken as a communication bridge that relates the reality of the world. It compiles the reality of the world, recognizes, select, classify, simplify, and symbolize in a particular way so that a map is created. The map should be able to read, analyze, and interpret by the map user, and then they should imagine the reality, and that reality should be much more closer to the real world. That is how this entire vicious circle gets closed across, and that solves different business problems that might have taken a long time for us to analyze with different facets, different aspect, different analysis. It would have taken longer time, and that shortens our time period, that shortens our computational time, that shortens our monetary value, and that is how you extract the value from GIS and get information, get different kind of analysis done. What are my communication objectives? That is the first question when you start a GIS project. What map I should use, what scale we should use, what kind of different thematic map has to be utilized, what kind of qualitative data has to be analyzed, what kind of quantitative data has to be analyzed. All of those analysis should be the basic nuance, or should be the basic point to start with, to understand what is the objective of those communication. And that is how it is not a monolithic way of communication. It is a communicative way of communication with the customers or with your targeted audience, and that is how it gives you immense value, because as soon as you do the query, it starts getting you the result. As soon as you start analyzing the data, it gives you much better insight that you might not have got through, that you might not have got through that you might not have got through a general analysis of the data. What projection should I use? There are more than 3,000 projections. No projection is perfect. Every projection will have its own distortion. Shall I use it at all or not? So basically, the question is like, what different kind of projection to be utilized? What we will lose upon? That are the prior input that should start with any of the system, than deciding at the later stage, like shape, area, distance, direction. All of those components become the core component of any GIS analysis at any point in time. How much detail should I include? How much detail should I include? What should I omit? What a scale of the platform has to be there? What are the aggregated information? What generalization of a map has to be done? What different kind of data has to be clubbed together? All of that has to be analyzed. How to simplify the map? How to generalize the map? What are the different displacements that need to be taken care of? How to typify the different requirements, how to classify, how to define, how to exaggerate. So all those analysis has to be part of component, or part should be the component of any geospatial solution or any of the GIS solutioning that you are planning across. What factors control my design when I'm designing a GIS platform? My objective should be clear. What kind of map form I have to create? Who is my audience? Shall I create a complex maps, or shall I create a complex database that is only for the advanced user? Or it has to be easy for any end user, those who do not have any understanding of mathematical calculation that is being run run in the background. It has to match with the reality, or authenticity has to be analyzed across. Generalization and a scale has to be defined based upon the business value that you want to extract across. Technical limits has to be talked about. What are the technology limits? What information you cannot extract out from the system? What information you cannot derive as a value from this GIS platform? What are the different conditions of the usage? So that also defines what kind of symbology, or the size, or the color has to be selected across. Always think of the user when you are defining a GIS system. That is the core of any solution that you make across, or then when you are using as a platform. I will talk about one of the interesting company or interesting method where GIS has been utilized in a very typical, very different ways. That is aim locate. It was a global addressing system. Again, a very different way of analyzing a geospatial location. Say in an address, you don't have the address. You talk about a migrant labor, those who have migrated from one place to the other, where their houses doesn't have a house number, they don't have the street name, they don't have the locality. How you will map them on a GIS platform? Whether you will ask them the latitude, longitude, they may not be knowing it actually. So this is one innovative way through which the entire world is created as a grid. A 10 meter by 10 meter grid is categorized as a postal code, and within that 3 meter by 3 meter, 10 kilometer by 10 kilometer grid is created as a grid that is called a postal code, that is derived from the first 3 digits of any of the latitudes. If you look at latitude and longitude, numbers are here as a combination of postcodes, and then the next numbers are becoming the addresses of that particular location. So those numbers are one of the very, 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 very hierarchical numeric way of presenting. So 6-digit postcode
6-digit numbers or 4-digit by 4-digit number is a unique identifier. You can plot it on a map, and that is how you will get this result as unique identifier or unique address for that particular location. Certain companies across the globe, whether it is a NAS system or Google code or map code from TomTom or a NAS code from the NAS companies or the Google code from Google gives you such kind of information. Interesting company, what 3 word? That gives you 3 unique word for a location. That is also a kind of GIS application, and every application with its limitations has defined how those point location can be mapped across so that different kind of analytics can happen with different kind of data results can be extracted out. Again, whenever you get the question, so where are we exactly? Remember about all the GIS solutions, and those solutions will provide you the result. Those solutions will provide you the result to do your analytics, to do your analysis, and get you the result, get you analytical results. Global information flow is very rapid, real time, fast, and broader. This is one of the example where in 16 minutes before and after the Japan earthquake on 3/11/11, these are the snapshot of a reply from and to Twitter user in Japan. At 2:30 p.m. in Japan time, before the earthquake and the tsunami that happened across, this was the usual traffic of these colors. If you look at these colors are the usual traffic or the Twitter. So the different tweets that were happening across, those Twitter results were those Twitter communication, comments, likes, and all of those activity were happening across. But as soon as this tsunami occurred, just after 16 minutes, see the volume of those Twitter interaction that was plotted on a GIS platform. So this shows across in the real-time world. If you do the monitoring, these are the technological solutions that becomes more important to utilize or analyze, analyze the platform and the accuracy of the data. Some of the very interesting map. If you have to create Pangea through the modern or recent map that is available, or from the recent boundaries that is available, this map will look something like that. And it is itrio.net via Reddit. They published this map. This was one of the most interesting map that was created on a GIS platform. I wanted to showcase that to this young group actually. Again, another way of GIS representation. Look at the population by latitude and population by longitude. So this is a geospatial or GIS data representation of the attribution data of population, and that is how it is represented across. Again, if the population, if I talk about 2% of the Australian population lives in this entire maximum part of Australia, that is like that gives you a greater insight, and that gives you like a lot of value of information that you can extract from those business or GIS layers. If you reverse the map, north is reversed back, and everything from northern hemisphere is brought down to the southern hemisphere, and everything of southern hemisphere is brought to the northern hemisphere. How the map will look like. So this is another interesting way of representation, another creative way of looking at the world from different dimensions. This is what I always want to have actually, like the world map tattoo on my back, wherever the country, whichever I have visited across, marked it with those colors. Probably I would do that at some later point in time. The countries where the metric system is not utilized, that is marked in red. So you can understand like so much greater insight you can have. Again, only 22 countries where the countries in the world where Britain has not invaded. So this insight, this gives you greater insight, and these are the insight. If it was supposed to be done manually, it would have taken much of the research time, much of the analysis time, which you can extract the value in within second or fraction of a second or fraction of a minute. The areas where the Google Street View is available at that point in time. Like actually, this map is created some 10 years back. Probably many of the things might have changed across, so this value would have increased now. But I could get only of this image. So this gives a context like the image relevancy remains for a certain period of time, which may change from time to time. This is a nightlife uses or nightlife uses of a nightlife uses based upon date and time. Internet uses actually like during the daytime and the nighttime, how the internet is being used in different parts of the world. This entire circle is having more people living anywhere outside this circle, and this is not even like this is one of the smallest portion of the entire Earth actually, which has got maximum population located. So what it gives you a business opportunity to do the analysis like where population matrices are important to different kind of business. Such GIS platform will give you the value out of it. Think of the use case. You have to do a multi-layer analysis of the proximity analysis, last mile delivery analytics, location analytics. You want to do the geofencing or geo-trigger. So say like if some person is nearby you, a geo-trigger SMS can go in to him. So all those use cases like hyperlocal advertisement or hyperlocal medias. So all of that become an important aspect of any GIS use case, whether it is geocoding, routing, or it is unlimited basically, or a supply chain, it is unlimited. I'll show you a video that will help across in analyzing the typical use case. So I hope so, like you should be able to hear the voice as well. Let me see if you can, or you can raise your hands, or I'll share across the presentation. You can look at it. So I'll tell you about this. So this store is a unique store where different kind of shoes are sold across. Different kind Nike shoes or different shoes are sold across, and let me see. Somebody is pinging. Just give me 1 second. Jyoti Kumar and Satakshi Bala have raised their hand. Do you have any question for now?
We will have questions at the end. So Jyoti and Satakshi, if you have any question, we will have a question answer session. So please wait for the question answer session. Okay, thank you.
Yeah. Not happening.
Yes, Nishant, you carry on, please.
Just give me a second. Actually, my Microsoft Word has crashed across, so let me reopen the slide.
Okay, please. In between, there is one announcement that any students, if you wish to ask any question or if you wish to give your any comment, be brief, and we'll wait for the question answer session immediately after the presentation of Dr. Nishant. Thank you.
So I was talking about this video actually. So this is a store in Guatemala, and this is a shoe store in Guatemala. And what they did actually, like a very interesting aspect, like they were inside a mall, and in that mall actually, various other shoe store was available, like Nike and Reebok and every other shoe was available in that mall. they were having challenges, and they utilized the geospatial services or the GIS application to get those customers, those who are going to different stores, to get to their store by offering a unique way of sending coupon or sales offer. So what they did, like whenever you visited a nearby store, they started offering you a coupon like, hey, your time starts now on their mobile, and whatever the number is left on your mobile is the discount amount that you're going to achieve from that. So see this video. This is very, very interesting video. I'm not sure if you're able to hear to this music or not. Actually, can somebody confirm me if you're able to hear the music?
No, music was not available.
Just 1 second. Give me 1 second. Let me do that. Just give me 1 second.
Dan in the Nike store.
Can you hear it now?
Dan in the Nike store.
Yes, yes.
Deptt is the trendiest shoe store in Guatemala, a brand known for its edgy, cutting style and a store known for its unique discounts and limited edition kicks, including brands like Adidas, Nike, and Reebok. An icon for the sneakerhead subculture, with over 60,000 fans on their fan page in less than a year. They needed to launch a new promotion that lived up to their hardcore fans, an innovative way to earn their discount. They created Hijack, an enhancement to the official media by our customers. Every time one of our sneakerheads enters one of the stores, it triggers a special notice with a promotion. Hijack sends an alert to the person's mobile. Discount starts at 99% and decreases by 1% every second that goes by, making the countdown stop until you reach our store. More than 600 customers were hijacked from the competitors in a week. One customer, Pedro Rodriguez, got a record-breaking 89% discount. This is the first promo campaign that started the sale in the competitors' stores.
I hope it was available to all of you now.
Yes. Yes, Nishant, it was available.
So see the interesting use case. In this entire use case, if you look at, there was no mention of GIS. There was no mention of location analytics. But in the background, all the analytical value was extracted from the GIS, all the geospatial layers aspects actually. That is where I land to this page as a career option in GIS. Is it limited to mapping or the analytics team or the planning or the strategy? No, it is not. The world of GIS doesn't only imply for the mapping solution company or the strategies company or the analytics company. There are multiple avenues available for GIS. Starting from Google, different departments are there, where the navigation or the mapping team is there, or the routing team is there, or the geocoding team is there. So all those avenues are available over there. Whereas in different deliverable companies, like e-deliveries companies, they deploy different kind of GIS GIS experts for their analysis. In supply chain management, GIS is booming up, and a different kind of geospatial analytics is getting utilized for geospatial solutions. In many of those, in many of the wild laying companies, they are using routing or navigation data for the geospatial analysis to optimize the cost of laying over the cable. When 5G and the 3G and the 4G infrastructure network upgradation started, this GIS was extensively used to optimize the cost across. Chromecast is one of the companies those who utilized it. I will give you one use case where geospatial or GIS data was utilized across in Bank of America. So Bank of America started providing a customized user experience to their customers by using GIS. So whenever a person used to put up a request of visiting a bank branch, the map location was sent across to their mobile, and that is how it started with the journey. So what route has to be followed? Your parking slot has been blocked, and whenever you enter the bank, a personal manager used to greet you by your name with a customized requirement. So these are the different GIS values and career options that is available. The world is all yours. It all depends how you utilize GIS. So think of a GIS as a philosophy or as a science rather than as a tool to get your career opportunity. So I gave you the tools, shown you the tools to utilize in different platform or different work that needs to be done. I use certain images. There are various images that was utilized. I cannot give the acknowledgement to each and every individual contributor to those images. But yes, I acknowledge that those images are not mine, and it was used from various sources, and my contribution has been listed across in this presentation. So that is how I will come to the discussion session where we can discuss across. So let us start the discussion now.
Any student or research scholar, young faculty members, if you wish to say something, if you wish to ask something, Nishant is there to answer your queries and questions and guide you. And then in the later phase, we will have the formal vote of thanks and comments from my side. Nishant, as many of the first year students are there, this is the first lesson towards GIS to them. Though yesterday I have given them few points just to understand as to what is GIS and all. So many of the postgraduate students are also there. And the system also, as you can see, they're sitting in the classroom. So Nishant, may I request you to just encourage the students about the careers which is available in GIS, so that the students, they are more motivated. They have opted geology as their core subject, and they wish to go through into the remote sensing and GIS segments. So what are the career opportunities available for them in the current scenario?
Let me start with my career opportunity. Actually, I am a core geologist. I started my career as a core geologist, and I was a field geologist. Actually, I was a field geologist. Started my career as that, and then moved into the world of GIS and remote sensing in DRDO. So where this remote sensing and GIS can be utilized. Today, if you look at like many of the disaster management applications that is happening across, so those disaster application or the crop estimation so starting from disaster management to crop to the wildlife management to the natural resource management, everywhere the GIS application can be applied and is being applied. Currently, like to estimate, like I started my career when I started working upon landslide hazard zonation mapping. Actually, that was done on a GIS platform. You cannot go to those remote areas. Actually, you have to depend upon the satellite images. Being in DRDO, actually, like when you don't have the access to the other part of the country, So you have to do the analysis based upon the satellite and image interpretations. That gives you a lot of career option. So starting from wildlife, starting from deliveries, starting from e-commerce business, everywhere the GIS options are available. You need to be. So if you have taken an optional GIS, my suggestion is don't be don't be a system operator. Don't be a system operator. Always ask what it is doing. Actually, you should know the science and theory behind that, rather than going to the start button, go to the program, go to ESRI or a map info, go to the start a file, take a file and do the analysis. It is not the objective of GIS software. The GIS software is all about how you want to utilize different kind of layers together to do the analysis. Actually, that is how the GIS should be taken across. So sir, my summation is the world is unlimited for GIS. It can be applied anywhere, starting from a classroom, how the student can sit across from one bench to the other during this COVID time, and then from whichever remote location a student are attending the classes, I can note down all the locations and I can analyze who all are there in Patna, who all are there in Delhi, who all are there in Hajipur, and all those locations can be marked across. What different kind of information has been laid across to those people. So this kind of analysis can be done. At the same time, if I have to deliver a smartphone to those students to do the courses online, where the deliverable has to happen, what routing option has to start from the warehouse to the location. So all those analysis is required as a GIS requirement for any of the industry, any of the company.
Thank you, Nishant. Really wonderful presentation on GIS Day. And I believe, and I'm sure that the students and faculty members, we have really paid our sincere tribute to Roger Tomlinson, on whose birth anniversary we are celebrating this GIS Day. Kindly mute your mic. The students, you are requested to kindly mute. The students are giving you a big round of applause to the presenter of today's lecture, Dr. Nishant. So what I'm saying is that today's day we have celebrated with your presentation, and the students must have been motivated to go detailed and get more into the GIS. So for a formal vote of thanks, I may request Shekhar, our faculty member. But before that, I must say that Nishant is basically a professional, but his presentation, his professional career is blended with the academic presentation which we had. So blended presentation, professional plus academics, really thankful to you. Now, Shekharji, may I request you to propose a formal vote of thanks to today's presenter, Dr. Nishant. Shekharji.
Sir, am I audible?
Yes, you are audible.
Yes.
Namaskar. It's a matter of immense pleasure that I have been provided with this opportunity to give a vote of thanks. First of all, it's a GIS day. So happy GIS day to all. Since we are living in a software-based world with lots of ease in day-to-day life, particularly GIS from the ease of transportation to the advanced defense surveillance system. I would like to thank today's speaker, Dr. Nishant, an alumnus and head of products, Times Internet, for delivering a wonderful lecture under the Platinum Jubilee lecture series. Sir, it's a privilege to have your ideas on this topic. And I personally feel that it was quite brilliantly delivered, from history to the definition, its working, and the present trends in the GIS and its working. I would like to thank our head, faculty members, and staff of this department and also to our technical team for organizing this lecture series and their tireless work. I would also like to thank distinguished guests, alumni of the department, our students, research scholars for their participation in this lecture series. Uh, Sir, I feel that everyone gets benefited with today's lecture, and thank you very much, sir. Thank you very much.
And on behalf of the Department of Geology, I must thank Professor P.K. Joshi from Jawaharlal Nehru University, who has joined this program, and throughout he has continued to be with us. So thank you, Professor Joshi, to be with us. And in the future also, we would like to have your guidance in this field, and the students also will be getting some benefit interacting with you. So at last, before we close the session, myself and Dr. Rabindra Kumar, both the PG and UG head, would appreciate Nishant. And this is just a token memento from our side. On the occasion of the Platinum Jubilee celebration. So this will be posted to the address which I have, your residential address. Is it okay? Residential address, you'll be getting it. Okay.
Thank you, sir. Thank you very much, sir. Thank you, sir. Thank you very much. Thank you very much, sir. My honor.
So before we close the session, Nishant, I will request you to be with us when we'll have the grand celebration of Platinum Jubilee during the month of February. We have tentatively fixed 13th of February. We will fix the date and then we will let you know. So thank you again, Shekhar ji, Nishant ji, and all other friends. And to inform Nishant that immediately after this session, we are going to have the quiz for the students based on your presentation and GIS which we had. Thank you, Nishant. Thank you once again.
Thank you, sir. Thank you, sir. Thank you very much. Thank you.